We now describe an ellipse. So what is an ellipse? Ellipse is the set of all points in the plane the sum of whose distance from two fixed points in the plane is a constant. So if you have a point on the ellipse, then it has distance measured from two fixed points. The sum of these distance is a constant. So let us see. So we have a point on the ellipse, and you can see it is connected to two fixed points which we will call focus, and the sum of distance to first fixed point plus the distance to second fixed point is constant. So we will write this down. So let us add another point. So now we have 2 points on the ellipse and they are connected to two fixed points which we call the focus. So this is focus 1, fixed point 1, this is focus 2, fixed point 2. So say this is point A on the ellipse and this is point B on the ellipse. So from point A we have two distances, AF1 plus AF2, this is a constant, and this is equal to BF1 plus BF2. Another way to think about the ellipse is to think F1A to F2 is a piece of string, and the length of this string remains constant as we go around the ellipse. Now we talk about labeling the points of an ellipse. So the first thing we talk about is the distance between the foci. So distance between foci or foci, this is plural of focus. So distance between these two foci is 2c. So this is focus 1, focus 2. So focus 1 is at a distance c from the origin or the y-axis. Similarly, focus 2 is at that distance c from the y-axis. So we mark this point here as 0, b, and the corresponding point here is 0, minus b. So this point here, this is called the vertex. So vertex is precisely where the axis which contains the focus cuts the ellipse. So this is a, 0 and we have minus a, 0. Now we want to talk about the minor axis. So the minor axis goes from 0b to 0 minus b. So notice that the minor axis does not contain the foci. So the minor axis does not contain the foci or foci. So the minor axis length is 2b. Now the major axis goes from minus a0 to a0. Notice that we call the axis as major axis only if it contains the foci. Now you can see the length of the major axis is 2a. Now the length of this segment is b square plus c square because we have a right angled triangle here. So minus a0 is called the vertex. We have the origin right here. Our objective is to compute c in terms of a and b. So I have labeled points a and b in the figure. So let us show the distance. So f1b plus f2b is equal to f1a plus f2a. So this holds. So this holds from the definition of an ellipse, because A and B are two different points on the ellipse. So the distance here is f2b is a minus c, because 0 to f2 is c and 0 to b is a. So f2b is just a minus c. What about f1b? Now f1b first contains f1 f2, which will be 2c, and then it will contain f2b, which will be a minus c. Now we just do the cancellation. Now notice that f1a and f2a have the same length, that is square root of b square plus c square. So now we just do the algebra, and we get a square is equal to b square plus c square, and c square is equal to thus a square minus b square. Or you can see that c is equal to square root of a square minus b square. Now we want to talk about eccentricity of an ellipse. So eccentricity of an ellipse is generally denoted by E, and this E is given as c over a.